Alright, so let's have a look at covalent network lattices. Now this is covalent network bonding, but down at a state where it's solid, so cooled down to where it's a solid. Alright, so let's have a look at what covalent bonds are. Remember, covalent bonds are where atoms are sharing electrons. And because these two share the electrons, it's held together by the electrostatic force between this positive nucleus and this negative pair of electrons that it's sharing, and this positive nucleus and this negative pair of electrons that it's sharing. And remember, the two nonmetals overlap to form covalent bonds. So they overlap, their atomic radius overlaps, and they start to share electrons, and that forms the bond. So what is a covalent network lattice? Basically, this is when a lattice, a solid lattice, is covalently bonded amongst all of the participants. So the chemical formula, like with an ionic bond, an ionic lattice, needs to be expressed as an empirical formula, so the simplest whole ratio of the elements within the lattice. They are hard and have a very high melting point. So the breaking and melting requires overcoming some very strong covalent forces. They are insulators. No free electrons to flow. All electrons are bonded to atoms. There are no ions. And we see down here, both of these are forms of carbon. Carbon has various forms or allotropes. An allotrope is the shape of an elemental crystal lattice. There's various allotropes. Here we have diamond forms like this, whereas here we have graphite. Now graphite is these little hexagon shapes. Okay, each carbon is made its 4 bonds, its little hexagon shapes, and they slide. There are van der Waals forces in between here, but that's it. Whereas here, these are all covalent forces. So this is a covalent network, but it's a flat covalent network. Here's a 3D covalent network. And if we have a look at the other example we tend to use is silicon dioxide. So it is SiO2, it's a covalent network. The ratio, however, is for every silicon atom, there are 2 oxygen atoms. Alright, I hope that made sense. If you have any questions, feel free to ask them in the comments below and we'll get back to you as quick as we can. Thanks for watching. Bye now.